Hello friends, let us learn about symmetry of two-dimensional figures. Symmetry of two-dimensional figures can be checked either by reflection or by rotation. In class 6, we shall learn about reflection symmetry. Here, I shall define reflection as the flipping of a two-dimensional shape along a mirror line. The new shape thus obtained will face the original shape in the opposite direction. Let me explain this with the help of a diagram. Now look at this diagram. We have a triangle ABC. Suppose BC is the mirror line. You can see I have given this symbol of a plane mirror. Now A is a point object here. In physics, you must have already learned that the object distance from a plane mirror is equal to the image distance. The same is the case in case of reflection symmetry. So, if I consider the point object A, let me show you its perpendicular distance from this plane mirror is suppose 2.5 inches. So, I have to measure 2.5 inches on the other side. As I said earlier that reflection is the flipping of a two-dimensional shape along a mirror line. Here the mirror line is BC and I have measured the object distance from the plane mirror and also the image distance from the plane mirror. Here A is the point object and A dash is the image of A. Now the point B and C already lie on the mirror, therefore their image distance and object distance will be 0, that is the image and the object is the same point here. So now when I join them, see what happens. So here I have obtained the image of point A as A dash. In other words, I can say that triangle C A dash B is the reflected shape of the given triangle A C B. Okay. So, you may be given a question as complete the figure to make a symmetric figure, considering suppose BC as the mirror line in this case also. Now, here you can see I have drawn a quadrilateral and I need to complete this figure to make a symmetric figure. So, suppose I say that now A and D are the two points to be reflected along the mirror line BC. In the same way, I will be measuring the distance of A from the mirror line BC. It is 2.3, on this side also it has to be 2.3. We are measuring the perpendicular distance of the point. Okay. Same here also. Now, when I join them, I obtain their images as A dash D dash. Join them in this way. Have you seen? We obtained the reflection of the figure ADCB as A dash BC D dash. Okay? I suppose I am clear. Now, you can see a square here. Now, if I fold this figure along the diagonal, what do you observe here? The boundaries have matched itself on both the sides, right? So, this mark, that is the diagonal, can be considered as one of the mirror line. In other words, I can say the diagonal is one of the lines of symmetry. Next, the other diagonal also if you fold, along the other diagonal, you will again see that the boundaries or the figure matches itself. Okay. Now, if I fold this way also, if I fold this way also, I see that the boundaries coincide. So, this is another line. This way also we can fold, and so in total I have shown you the 4 different lines for a square that can act as a mirror line, right. So, in this way I can fold different 2-dimensional figures. Here I have the shape of a heart. So, if I fold in this way, you can see the edges of this figure has matched exactly. So, this particular line can act as the line of symmetry, but you try it in a different way. If you try it in this way or any other way, you will see that the boundaries do not match one another. So, that particular line cannot be considered as the line of symmetry, whereas if I consider this particular line, you can see the boundaries have touched one another perfectly, right. So, this shape has a single line of symmetry. I shall draw the diagrams and show you how to draw the lines of symmetry. Now, I am showing you how to identify the line of symmetry or how many lines of symmetry a 2-dimensional figure can have. Look at this rectangle. Here a rectangle can have this particular line as the line of symmetry, or if we fold it this way, you can see we can obtain the second line of symmetry. Now, diagonally is it possible? Let us check. Diagonally, when I am trying to fold, what do I observe? See, the vertex C and the vertex A do not coincide. Diagonally, when I try to fold, diagonally if I fold this 2-dimensional figure, see what happens? The vertex A and the vertex C do not coincide, right. So, the diagonals in case of a rectangle cannot be considered as the line of symmetry. So, here there are only 2 lines of symmetry that bisects the opposite sides of the rectangle. Similarly, look at this arrowhead. I can fold it in this way. You can see the boundaries match itself, right. So, there is only one line of symmetry in this case. In case of a regular hexagon, see, the opposite vertices can be joined using a line that can act as a line of symmetry. So, as there are 6 vertices, for all the vertices I have obtained 3 diagonals along which the figure when folded the boundaries match. Apart from this, when I try to fold along the opposite sides, then also I find that the vertices have coincided. So, the boundaries also match one another. So, here for the 3 pair of opposite sides, I will obtain 3 more lines of symmetry. So, in total a hexagon will have 6 lines of symmetry. In case of a rhombus, see what happens when I fold it diagonally. The vertex A and the vertex C coincide. So, the diagonals can act as a line of symmetry in case of a rhombus. A rhombus has 2 diagonals. So, both the diagonals can act as the line of symmetry for this figure. Now, for the sides, if I think of taking the midpoint of the sides and try to fold the figure in this way, see what happens. The vertices do not coincide. So, the bisector of the sides will not act as the line of symmetry in case of a rhombus. Only the diagonals will act as the line of symmetry. Next children, look at this figure. This is a parallelogram. It is neither a rhombus nor a square, but it is simply a parallelogram. Okay. Now, in this case, if you try to fold along the diagonals, the vertices do not coincide, right? And if I try to take the opposite sides and fold it, then also the vertices do not coincide, neither the boundaries match. So, a parallelogram is an example which shows that it does not have any line of symmetry. So, I have now some figures already drawn here. Now, how to draw the lines of symmetry, children? You have to identify for a square the midpoint of the opposite sides, right? After identifying the midpoint of the opposite sides, you have to join the points. So, when you draw the lines of symmetry, please remember you have to extend the line beyond the figure and mark arrowheads on the line, right. So, a square has 4 lines of symmetry. So, these are the 4 lines of symmetry I am showing you. This is how you draw. Okay. So, these are all the 4 lines of symmetry. Next, for our rectangle, I have already shown you the diagonals cannot act as the line of symmetry. If you consider the midpoint of the opposite sides and you join them, you will get the mirror line, in other words known as the line of symmetry. So, there are 2 lines of symmetry for a rectangle, right. In case of the other shape, that is the heart, we have a single line of symmetry. So, this is the single line of symmetry. For a hexagon, I told you it will have 6 lines of symmetry. 1 joining the opposite vertices, 1. In case of a hexagon, we have 6 lines of symmetry. Do not forget the arrowheads. So, we are joining the opposite vertices to obtain the lines of symmetry first, and then we will be joining the midpoint of the opposite sides to obtain the other lines of symmetry. So, here this is the 4th one, this is the 5th one, and finally the 6th line of symmetry. So, a hexagon has 6 lines of symmetry. Now, look at this shape. This particular shape will have only 1 line of symmetry. I think I have already made this figure using a chart paper. I hope you can see the figure. Now, if you fold this in this way, you can see the boundaries match exactly. So, this particular figure has its line of symmetry along this part. So, it has only 1 line of symmetry. Now, look at this equilateral triangle. The angle bisectors will be the line of symmetry here. So, this is how we draw the angle bisectors, and for the 3 vertices we have 3 angle bisectors, and they are the lines of symmetry. So, in case of an equilateral triangle, there are 3 lines of symmetry. This figure has 1 line of symmetry. Now, how many lines of symmetry does a circle have? Now, the circle must be divided into equal areas when I draw the line of symmetry, right. So, which particular line can divide the circle into 2 equal halves? What do you think? It is the longest chord, that is the diameter that divides the circle into 2 equal halves, right. So, how many diameters can a circle have? We all know a circle has infinite diameters. So, there will be infinite lines of symmetry for a circle. So, as many diameters you can draw, but I know as there are infinite diameters, we will not be able to draw all of them. I am just showing some of them, and write your answer as there are infinite lines of symmetry for a circle. Right. For these figures, I had already folded the shape and shown you earlier. It has only one line of symmetry. Okay. This particular diagram will also have only one line of symmetry. Similarly, this trapezium will also have a single line of symmetry. So, this much for today. I hope the concept of reflection symmetry is clear to you all. Thank you for watching this video.